create a matrix multiplication Java program, and we will try to use the same concept that we learned in our last class, how we can calculate or how we can do a matrix multiplications, right? So you can see here that my class name is matrix multiplications, and that is available under com.demo.array package. Let me double click here. Now what is our aim here? So our aim is taking the input for first matrix, then taking the input for second matrix, check that is it possible to multiply these two matrix. If it is possible, then try to multiply their two matrix and finally print the result of the final matrix or the result matrix. So the first step we have to do, that is basically we have to create some variable to take the row and column count of first and second matrix. So let's create some integer variable, something like this: r1, that is basically row of or row count of the first matrix; c1, column count of first matrix; r2, row count of second matrix; and c2 for column count of second matrix. Okay, so I have created four integer variable for row count and column count of first and second matrix. Now we have to collect the value from user, right? So we definitely use the scanner class instance and try to collect by giving some message to user so that they can put the exact value. So here I am not going to tell you how to create a scanner class instance and how to take the input. Okay, here I am trying to copy paste the existing class code base here so that we can save our time. So here I have simply copy paste the code base. So this is basically scanner class instance, and first message is enter the row count of the first matrix, and that is collected under r1. Similarly under c1 we are trying to collect the column count of the first matrix. Similarly r2, the row count of the second matrix, and under c2 we are trying to collect the column count of the second matrix. Okay, so our printing statement and collecting value is done. Now our next step should be checking the conditions, that is the multiplications is possible or not with these row count combinations. And we know that for multiplications, number of column in first matrix should be same with the row count of the second matrix. If this is equal, then only multiplications is possible, and we already put the c1 value and r2 value, right? So first we have to create a if conditions. If these are not same, then we will simply give a message to user that multiplications is not possible. So we will create a if statement like this: if c1, that is basically column count of first matrix, is not equal to row count of second matrix, then we are giving a message that matrix multiplications is not possible with these combinations, right? But if these are same, that is multiplications is possible, and that's why we will make a else conditions, and under that we will try to do our exact logic. Now under this else block, our first step should be creating the matrix. So this is matrix A and this is matrix B, and the row and column combinations or row and column size we have given here, like R1 and C1, here R2 and C2, that we basically collected under this variable. Okay, now what will be our next step? Our next step should be creating the result matrix. Okay, and to create a result matrix, I have given the comment that we basically learned from yesterday class, that the row and column of the result matrix is nothing but row of first matrix and column of second matrix, right? That is basically R1. So you can see R1, and the column of second matrix is C2. So with this help of R1 and C2, we'll try to create another matrix, that is basically our result matrix. We will give the name as C, and we will try to create that here. So now this is my result matrix, or we can give a C name here, and you can see R1 is the row count and C2 is the column count of that result matrix. So our matrix initializations is done. Now we have to take the input for first matrix and second matrix, that we already learned in our number of previous examples. Now to do that, I am not going to show step by step because we already learned how to take the input for a matrix. So I am just trying to copy paste the existing code base so that it can save our time. So you can see I have copy paste the same code base that we learned previously. This is basically first matrix input taking logic, where this is my first iterations where it says the row count, that is nothing but R1, and the nested iterations is basically column count, that is nothing but C1 for our first matrix. And here we are trying to collect the value of each column element or each element of the first matrix. Similar way for the second matrix we are trying to use again the two iterations concept. So first one is for total row count R2 and second one is for total column count, that is basically C2, and we are trying to collect the element value for second matrix. So once our matrix value collections is done, that's mean our first matrix and second matrix is ready. Now what will be our next step? So our next step should be printing the first and second matrix, and we know the exact syntax. I am trying to just copy paste the code base from the existing one and trying to show the exact printing statement for first matrix and second matrix what we actually collected in this step, right? So once our printing statement is done for first matrix and the second matrix, then our next step is creating or calculating the multiplications of these two matrices, and here our exact logics need to be understand. Now here I am giving a printing statement something like this third matrix. Okay, now what is the third matrix row count? So we know the row count of the first matrix should be the row count of the result of third matrix. So as the row count of the first matrix will be the row count of the third or result matrix, so that's why I am giving here a for loop something like this where I less than R1. Okay, so once this is done, then under that we have to make the column count iterations, right? And we know the column count of the final or result matrix is same as column count of the second matrix. So what is the second matrix column count? That is equal to C2. So we have to create another for loop like this. So here you can see J is less than C2. C2 is basically column count. Okay, now my for loop closed here. Okay, now under this for loop we have to actually implement our logic for multiplications. Now you can see here the final matrix we have already initialized with the name like C, right? So this is our result matrix or final matrix. Okay, and here under this nested for loop we first initialize that matrix with a 0 value. So how we can do that? We can do something like this Cij with 0. Now you can see here the very first time I is 0 and j is 0, so for C00 it is 0, and this will be initialized in each iterations of this nested loop. Now our actual product and summations logic need to be implemented here, which we already learned in our last class, that is basically this one, product and product summations. So this logic we have to implement here. Now here we again have to create another iterations logic where k should be start from 0 and k less than c1. C1 means the column count of the first matrix. Okay, now if you check here, so this is basically my first matrix, and how many columns are here? 3 columns are here, and we have to do the multiplications or product, and finally we have to make the summations of that. And you can see how many times this multiplication is going on. This is basically first, second, third, and this is nothing but our column count of first matrix. Okay, so that's why we use this is basically C1. Now what will be the logic under this? Something like this. So this is my first matrix and this is my second matrix. Now if you check here, so first time we are trying to make a multiplications with ith positions to jth position. So ith positions of first matrix, jth positions of second matrix. Okay, and based on that we are getting this type of product value, right? And finally we have to make the summations of that. Okay, so how we can make that summations? The syntax should be very initial phase we set it 0, so this is equal to that again the multiplications of this. Okay, now try to understand this one. Okay, so if you go to here, so you can see first it's 1 into 10. Okay, in first iteration it is 1 into 10. And what is 1? 1 is basically this one. So where I is 0 and j is 0, or the row is 0 and column is 0. So you can see here in first iteration k is 0 and here I is initially 0. So 0 and k is 0 means 0 0 position. So we are getting in 0 0 positions 1. So it is 1. Okay, then we are trying to multiply with 10. So what is this 10? 10 is this one. Again, if 10 is this one, this is also 0 0 positions of second matrix. So our second matrix is B, and very initial phase k is 0 and j is also 0. So B 0 0, that is nothing but our 10. So 1 into 10. Then it's come for the second iterations. Okay, so one, it is second iterations. Now k is 1. Okay, if k is 1, so here you can see in second iterations it is nothing but 0 and 1, because I is again 0 and k is now 1. So first matrix 0 1, first matrix 0 1 is basically 2. So you can see here the second iterations additions and then the multiplications is with 2 into 20. What is 20? 20 is here, and what is that value? Positions value is row 1 and column 0, that is basically 1 0. So what is 1 0? So you can see here for the second iterations of k, k is 1 and j is again 0. So this is basically 1 0 of second matrix, right? So we are getting the same thing, 2 into 20, 2 into 20. This is 2 and this is 20. Now the third one is 3 into 30. So 3 into 30, if you check again, that is basically for the next iterations. Now k is 2. So if k is 2, here I is again 0 and k is 2. So the first matrix position is 0 2. So what is 0 2? So this is my row 0 and this is column 2. So 0 2 is 3. So you can see this is 3, right? And now into 30, 30 means this one. And what is this? This is basically row 2 and column 0 means 2 0 position. So if you go here for the second matrix, now k we know this is 2 and this is basically 0, j is 0. So B or second matrix 2 0 positions, 2 0 positions is nothing but this one, 2 0 positions is 30, and you can see the 30 is coming here. Now our iterations is done. So once this iterations is done, we will get the exact summations of these three with these iterations. Okay, so once we get this value, then we have to print that value here, because we need this 140, right? Because our every iteration is done and our product summations is done. So 140 we need to print. So that's why I am printing it just after the iterations complete of this nested one. Okay, so that's mean it will first time print 140. This is nothing but this one. Okay, now it will go for the next column, that is basically it will come here and go for the next column, that is j. Okay, now j is 1, it come here again and I is still 0. So 0 and 1 positions. What is 0 and 1 positions? So this is my 0 and 1 position in the result matrix, right? Because this is row 0 and column 1. So this is basically my 0 1 positions. So for these 0 1 positions, the multiplications is this, and with this type of nested loop, again it will calculate this type of multiplication and additions, and finally it will print 14. Okay, so once it will print 14 here, so my column combinations for first row is done. Okay, so it will exit from this for loop, that is basically this one, and it will go just here. Okay, so that is basically I is equal to 1 or the next row. So we have to print this one in next line, right? So definitely we have to create a system.out.println, and where we will create that one, just outside this for loop where we basically complete our column iterations. Okay, so here we have to print a simple println statement. It's just simply go for the next line for next row iteration. Now I is equal to 1, and once I is equal to 1, again it will create two column iterations, and for these two column iteration, that is basically this one, it will again calculate this one and this one, and for once this one is done, it need to be print this 320, and once this will be done, that need to be print as a 32. So that will be calculated here in these iterations, and finally it will print here. Okay, and then it will go for the next round. Okay, that is basically next column, that is nothing but for this one, again the same calculations, print this one, and finally once it is done, it will just exit from this column calculations, it will go for the next row, and there is row conditions is fulfilled, so it will just exit from this for loop. So if you see here that we are trying to printing our result matrix, that is nothing but the multiplications process which we learn in our last class, that we basically did in this line actually. Okay, so this is the main logic for whole matrix multiplications. Okay, so if you understand this one, then you are good to understand whole the matrix multiplications process. So if I recap again, so very initial phase what I did, I try to collect R1, C1, R2, C2, that is basically row column combinations of first and second matrix. Then I checked is this row and column combinations is okay for multiplications. If not, then system give a message that multiplication is not possible, but if possible, then here we are trying to first initialize or declare our first and second matrix with row and column sizing. Okay, then we will try to make the third or result matrix with the exact step that we learned last day, what is basically row and column count for the third matrix or result matrix. Based on that, we declare and resizing the matrix size. Then we try to collect the value, element value of the first matrix, then the second matrix, and once the value is collected for each element, we will try to print the first matrix and second matrix. Okay, and once this is done, in our last iterations we will try to implement the exact matrix multiplications logic, and the exact logic is basically available in this 97 number line. So once this is done, we try to print that third matrix, and everything is now ready, and we have to save this file and try to run this file. And to run this file, we will try to check the same two matrix combinations and try to check the result is coming properly this or not. So now if I run this program, let me double click it here. So it says enter number of rows in first matrix. Okay, so if you check here how many row are there in first matrix, this is my first matrix, 2 row are there. Okay, so let me enter 2. Then it asks enter number of column of first matrix. How many columns are there? First, second, third, 3 column. Okay, so in first matrix we have 3 column. Okay, now enter the row of the second matrix. So the row count of the second matrix is 1 2 3. So if I make here 3, and it asks me enter the column count of the second matrix. What is the column count? 1 and 2. So let me make it 2. If I enter here, now it's asks the first matrix input, and for row 1 it asks column 1. So what is my column 1? So you can see column 1 is 1, then 2, then 3. So let 1, then the second column is 2, and the third column value is 3. Now for row 2, okay, so what is row 2? This is row 2, and this row 2 our value is 4 5 6. So enter column 1 for row 1, that is basically 4. So for this row 2, column 1 is 4, then column 2 is 5, and column 3 is 6. So 5, then 6. Okay, so our first matrix is done. Then it asks the value for the second matrix, enter row 1 column 1. So what is this? This is basically 10. So let make it 10, then enter the second column is 1, so we can make it 1. Then row 2 column 1, so this is my row 2, column 1 is 20, column 2 is 2, so let make 20, then column 2 is 2, again enter. So this is for row 3, column 1 is 30, column 2 is 3, so make it 30 then 3. Now if I enter, let's check the result. So you can see the first matrix 1 2 3 4 5 6, this is same 1 2 3 4 5 6. Now the second matrix 10 1 22 33, so 10 1 22 33. Now the result is 140 14 in first row, so 140 14 first row, then 320 and 32 in second row, 320 and 32 in second row. So you can see the same thing we are getting here with the simple logic that we basically did here. Though the program is basically 105 line, but the exact logic we written in line number 97. So this is basically main iterations, and the full logic for printing the third matrix, this is basically coming from 89 number line to 102 number line. So try to understand this logic with the combinations of this type of matrix value, and make some permutations, combinations, testing on this program, and try to understand the exact syntax what we did here. Though this program is look like a bit lengthy, but it is not a very lengthy one if you understand this PDF concept that we learned last class. So you can easily understand every process, every step, and you can implement this type of matrix multiplications program.
I believe this video has helped you to understand about the topic. Thank you for watching. Please do subscribe, click on the bell notifications and select all so that you don't miss any video from this channel.